Right. Hey class, how are you guys doing? I'm going to share my screen right now because I just finished recording this video, got it all posted to Edpuzzle, and realized that I had not shared my screen. So the whole thing I am redoing again. So today you guys are going to be watching the video for lesson 2.2, and I am going to go ahead and mix it in with lesson 2.3. I could almost put the other lesson 2.4 in with this as well, but I think that would just make the video too long. So we're going to just combine 2.2 and 2.3 into this video lesson. We are going to be talking about solving one-step inequalities. When we're talking about inequalities, before we really get into the nuts and bolts of how to solve them, I want us to talk about this inequality sentence without a variable. We know that 3 is less than 7. But what we're going to do with each of our different operations, we're going to add, subtract, multiply, and divide. One at a time for solving our equations, but I want us to see how does doing each of these operations actually affect my inequality? Does it keep my statement true or does it end up making my statement false? So for example, if I were to take 3 is less than 7, which is a true statement, and if I were to add 5 to both sides, what would we get left with? Well, 3 plus 5 is 8. Our inequality symbols this way, and 7 plus 5 is 12. And now what we want to ask ourselves is 8 still less than 12? Yes, it is. So what we just showed was that adding on both sides of my inequality keeps my inequality symbol the same. Okay, well, let's do the same thing and let's do some subtraction. If we take 3 is less than 7 and we subtract 5 from both sides, what are we left with? Well, 3 minus 5, that's -2. Here's our inequality symbol. We're not sure if it's going to be true or not, and then 7 minus 5 is 2. So is -2 less than 2? Yep, it sure is. That still keeps it a true statement. Okay, so what this shows us is that when we are adding and subtracting, it's not going to change my inequality symbol. So if I come over here to a new example and I say something like x plus 1 is less than or equal to 10, and I ask you to solve for x, you know how to do this already. We think undo, just like we did in the last chapter, where I see that I'm taking x and I'm adding 1 to it. So how do I undo add 1? Subtract 1. And subtracting 1 from both sides keeps my inequality symbol exactly the same. And 10 minus 1 is 9. So this is my solution. Any x less than or equal to 9 is going to give me a true statement in my original inequality. But see, most of these problems that we're going to be doing, the directions are going to say solve, which is what we just did here, and they want us to graph the solutions. So on a number line, we're going to graph this inequality, which is what we did in lesson 2.1. So usually what we do is we take the number that's in our solution, so this 9, we put it in the middle. Maybe we might go up 1 from 9 and down 1 from 9 just to show that we're on this number line. And then we need to decide in our graph, do we have an open circle or do we have a closed circle? Okay, when do we have the open circle? When it's just less than or just greater than. And so then when do we have the closed circle? When we have the equal sign in the inequality. Okay, so how about this guy? Do I need an open circle or closed circle? Closed circle because it has the equal sign in my inequality. Okay. Well, once we figure out the open or closed dot, the next thing that we need to put in our graph is the shading. And in our shading, we need to decide if we're going to go left or right. And we have to come back and read the variable first. And we say the variable x is less than or equal to 9. So numbers that are less than are going to be to the left. Again, we said there's this trick where if you kind of draw a straight line here, our inequality can point us in the right direction of our shading as long as the variable is listed first. Okay, because I can write this exact same symbol, this exact same inequality sentence, putting the 9 first and the variable second. And if I try and go like this and follow this arrow shading to the right here, I'm going to be wrong. Okay, so the only time we can look at the inequality to tell me which direction to shade, the only time that works is if the variable is listed first. Okay, so subtracting on both sides, here we go. We did one of those examples. Adding on both sides is the same. Let's do one though. Let's kind of switch this up a bit. Let's make it -4 is greater than x minus 8. Well, what did I do differently in this problem? There's really two things you could have told me. I have a greater than inequality, and I also moved my variable from the left-hand side of the equation to the right-hand side. But that doesn't matter, okay? So many people, when they look at this, are like, oh, let's just add 4 to both sides. And that's not what I want to do, though, because I want to be thinking, what's happening to my x? So find my x first, and then say, what am I doing to it? I'm subtracting 8. So how do I undo subtract 8? Add 8. So we're going to add 8 to both sides. We saw that adding to both sides keeps the inequality the same. It does not change the direction of my inequality. And so -4 plus 8 is a +4. My -8 and +8 cancel. Okay, and so before you go to graph this, I suggest switching it. Make it so that the variable is listed first. So variable, my number 4, the x is getting the point of the inequality. So make sure it's getting the point when you rewrite it. And then which inequality symbol is this? How do I read this one? It's less than. So on my number line, I'm going to put 4. I'm going to go up to 5, and I'm going to go down to 3. Does this need an open or closed circle? It's an open circle. On what number? The 4. Put that open circle on the number. Sometimes in the past, I've had people think, oh, well, it's less than 4, so I need to go to a number less than 4 and put my open circle there. And that is wrong. That is not how we do it. We actually put the open circle on the number 4 right here, whatever number we see. And because this is less than, my number is less than, shade to the left. You guys see how sometimes I do my shading in 2 different directions or 2 different ways? It doesn't matter how you do it, as long as I see an arrow at the end of it. We're all good. Okay, now adding and subtracting doesn't change my inequalities, but something interesting is going to happen with our multiply and divide. Have you guys seen this before? Do you remember which one ends up doing something interesting to my sign? Okay, so here we go. Let's go back to our example. Actually, I'm going to give us new numbers that are going to be a little bit easier to deal with. If I give you -1 is greater than -4. Now, again, sometimes this can be confusing because a number 1 is smaller than 4, but on a number line, -4 is further to the left than my -1. So -4 is less than 1, or 1 is greater than, sorry, -1 is greater than -4. Okay, so this is a true statement. Let's talk about some multiplying. If I were to multiply both sides of my equation here by a 2, let's see if that keeps my inequality symbol correct. Okay, what is -1 times 2? -2. And -4 times 2 is -8. Is -2 greater than -8? Yes, that is true. That is still a true statement. Okay, so multiplying doesn't change it. Ooh, but wait a minute. What if I keep the same original inequality and instead of multiplying by 2, what if this time I multiply by a -2? What is -2 times a -1? 2. And what is a -4 times a -2? 8. Is 2 greater than 8? No, it is not. So multiplying by a positive number doesn't change my inequality sign, but multiplying by a negative, this requires that I flip the inequality symbol. Okay, that is a really, really key, important piece of solving inequalities. So what would this look like? This would look like me giving you an example like this. -2x is less than 16. If I see this, I think undo. So what am I doing with the -2 and the x? I'm multiplying because the -2 is right next to the x. So how do I undo multiply by -2? Divide by -2. Okay, here's where I am doing the dividing by a negative. And so because of that, I need to flip my inequality sign. So my -2's cancel. 16 divided by -2 is -8. But now, instead of having the less than sign, I need to flip directions. The only thing I do is flip it. I don't change anything about whether it has the equal to or not in the inequality. That part doesn't change. It's just the direction. So now this is my answer. This is my solution. X is greater than -8. So on a number line, I would have -8. Down from -8 is -9. Up from -8 is -7. This one does not have the equal sign, so I'm going to have an open circle, and this is x's greater than, so I'm going to shade to the right. That's how this would work. What if I gave you this problem, though? What if the problem said, um, 4x is greater than or equal to -20? Okay. Well, what's happening to the x? I'm multiplying by 4. How do I undo multiply by 4? Divide by 4. Okay. Well, my 4 and -4 cancel, or my 4 multiply by 4 and divide by 4 cancel. So I got x, and I've got -20 divided by 4 is -5. But see, here's where some people will make some mistakes. They'll see a negative in the answer, and some people will think to flip the sign. But that's wrong. We do not flip the sign here. And the reason is because when we did the division, we divided by +4 in order to get x by itself. Even though dividing by my 4 resulted in a negative number, that does not mean that I have to switch my sign. Okay, so this is wrong. Whoop. Instead, we keep the original direction of the sign. So greater than or equal to -5. Keep the original sign because you divided by a positive number. And when we would graph this, we'd go to -5 on our number line, up to -4, down to -6, close circle because of the equal sign here. And then this is saying x is greater than, so we're going to shade to the right. Okay, so that's multiplying. What do you think is going to happen with dividing? Yeah, that's a really good guess. It's going to be the exact same. All right, so let's give you just a couple quick examples here to see this. Let's say if I had um, 5 is less than 10. And if I were going to divide by 5, 5 divided by 5 is 1. 10 divided by 5 is 2. If we keep the original sign, is 1 less than 2? Yep, it sure is. So dividing by a positive is going to keep the signs the same. All right, let's see how doing it by a negative is going to make it flip. Same thing, 5 is less than 10. But this time when I divide by a -5, 5 divided by -5 is -1. Is that less than 10 divided by -5, which is -2? Is -1 less than -2? No, it's not. Remember that on a number line, let's get 0 there. There we go. 0, 1, 2. On a number line, -1 is to the right of -2. So -1 is bigger than -2. So dividing by a negative requires that we flip a sign. Okay, there it is. So we'll say that multiplying or dividing by a negative is going to flip the sign. We're going to do lots of examples with this in class, and it's going to be pretty simple because all we're doing again is 1 steps. Just getting in the practice that adding and subtracting does not change my signs, keeps it all like normal. But when we're multiplying and dividing, when we divide by a negative, that's when we flip the sign. If we multiply or divide by a positive, it does not flip the sign. All right. Hey, quick reminder, next class period, there is going to be a quiz over 2.1. Okay, so this one's going to be writing inequalities. So changing it from words into a math sentence. Then we're also going to be checking solutions. So is a number a solution? And then also graphing. So like what we did with the graphing of the solutions, just simple things like x is greater than or equal to 10. Can you put something like that on a number line? So there will be a quiz on this at the start of the next class period. So make sure if you need to go over notes or if you need to do a little bit more practice, go for it and make sure you're doing that. All right, you guys have a great evening. We'll talk to you later.